All right, we have spent a ton of time on the parallelogram. I think it's time to go on to a couple other figures. Today we're going to study the rectangle and the rhombus and do some algebra with them, and then tomorrow we'll do proofs with them. First, I know this is not as part of your notes, but I just wanted to remind you about the family tree that we went over on the first day of parallelograms and why the rectangle and the rhombus are stationed right below. How many properties did we discuss of a parallelogram? 5. They're also here. Don't forget that, because here's what your brain's going to do today. New figures, new properties. But remember, any of the properties of the parallelogram, the rectangle and the rhombus still have. Opposite sides, congruent. So do these two. Opposite sides, so do these two. Diagonals, so do these two. Okay, get my point here. We're all good? But they also have some extras that the other two don't have. All right, so let's start with the rectangle here today. Notice number 1, A through E. If you want to read through them quickly, what am I just reminding you of? What are properties 1A through E? What's up, Paul?
Same thing as a
Darn right. I just want to remind you, even though it's a rectangle, it still has parallelogram properties. All right, please remember that. I know it's easy to say, oh yeah, whatever, but no, please remember that. All right, now what are some special ones that only the rectangle have and the rhombus and parallelogram do not? I think you guys know the first property I'm about to show you, which is all the angles are right angles. So all the angles are equal, okay? All the angles are right angles. Now let's get a little bit more sophisticated. Let's talk about the diagonals. The diagonals are congruent to each other. Both diagonals in a rectangle have the same length. So let's go a little further now. You know they have the same length, and they also do what to each other, because it is a parallelogram? They bisect each other. So let's think about this. They're equal in length, and they cut each other in half. What should we know about each of these 4 segments then? They're congruent. Think about it. Let's say this diagonal is 10. What's this diagonal? 10. And they cut each other in half. So what's each piece now? 5, 5, 5, 5. Right? So let's keep that in mind, that each segment is equal. This brings me to, and I should have typed this in this year, but I didn't, number 4. Property number 4. And it comes off this, what we just went over. Everyone see the 4 triangles that are formed here by the diagonals? What type are they? There we go. The diagonals form 4 isosceles triangles. Why is that? Why do I need to know that? Why is that a property? How's that going to help me in these algebra problems? This is why. Let's take one of the isosceles triangles here on the left. What's across from the congruent sides? What's across from those congruent sides? So you now know that this angle and this angle are now congruent. This one and this one are now congruent. Okay, that's where it's going to be helpful, knowing that you have 4 isosceles triangles. How's the rectangle look? All right. Right angles, diagonals are congruent. And then all the parallelogram properties. Anything on the rectangles? Rhombus. Oh, shocker. What's the first 5 properties I have listed here? Oh, yeah. Rhombus has parallelogram properties. All right, you ready for the extras that a rhombus have that a parallelogram and rectangle do not have? I don't think you guys are familiar with the rhombus as you are with the rectangle. Rhombus, all 4 sides equal. All 4 sides in a rhombus are equal. Are the angles equal? Angles equal? No, that's in a rectangle. Make sure we separate them. All right, what else is true? All right, let's go to the diagonals again. You already know they do what to each other? They bisect, parallelogram property. They also, ready? Bisect the angles they're drawn to. So on my diagram here, watch my arc marks and where I'm going to put them. They bisect the angles they're drawn to. You ready for a challenge? Why am I allowed to put only one arc mark on each side? Meaning all four are equal. How do I know that? Hi, Charlotte. Opposite angles are congruent, so if I bisect them, each piece would be equal to each other. Good work, good work. All right, so they bisect the angles they're drawn to, and the final property about the diagonals, they are perpendicular, meaning they form what where they intersect? All right, so take a look. They form right angles. So I may not have isosceles triangles, but I do have right triangles. That may come into play at the end of the class today. All right, hopefully you're ready to talk to your group a lot today, because that's what you're going to be doing on these next four. Not right now, though. I'll let you go in a second. Here's what I have here. In the directions, it says all four of those are already parallelograms. So they're already parallelograms. I'm giving you that. But please give me a better name than that now. So does everyone see number one? It's a parallelogram, but everyone see the little right angle in the bottom right? So it's not a parallelogram anymore. It's something better. What is it now? A parallelogram, and I stick a right angle in there. What is it? It is a rectangle. It is a rectangle. Now, my question to you guys. Come on, honors kids. Don't get ahead of me. It's a rectangle. Why do I only need to know one angle is a right angle? Why don't I need to know all four? Right? Why am I just throwing one up there and that's good enough? Even though a rectangle's got four right angles. Got something, Matt?
Because they're all congruent.
Well, even before that, here's a parallelogram. I got a right angle. What's got to be the opposite angle? Opposite angles are congruent. What's got to be the consecutive angle? Why? Because they're supplementary. Do you see just knowing one leads me to all the other three are right angles. So that's why you only need one in a parallelogram to make a right angle. All right, so here's what you're going to do in your group right now. I don't care how you get to it. Rectangle property, parallelogram property, heck, any geometry fact that gets there. Find me angles 1, 2, 3, and 4, please, in your group.
Okay, so you know how these are isosceles? So this angle right next to angle 1 is going to be 18. And since we know that the full angle is 90
Contribute. Contribute or listen, because I'm going to call on you, ask for the answer, and how you got it.
72. So angle 1 is 72. Is it 71 is 49? Wait, but we don't have like
Angle 1, 2, or 3, or 4. You choose whichever one you want, or whatever's available. 14. Start me off. What angle do you want? Yep, is 7. Yep. Go ahead.
I subtracted 18 from 90.
Good. Everyone, ready? One way you could get to angle 1. That's 18. That's 18 because it's isosceles, remember. And this angle has to add to 90, so angle 1 has to be 72. All right, right angles. All right, let's keep going. Another angle for me, 13.
Number 3 is 18.
Yep.
So it's alternate interior.
Yeah, that's the first one I always wrote down was angle 3 because it's alternate interior with the 18 I gave you. Remember, parallelogram property is still here, so those lines are parallel, make alternate interior angles congruent. 2 and 4 are left. 15.
Angle 2 is 36.
Angle 2, 36. Again, 7. Based on what we have right here anyway, this triangle's isosceles, 72, 72. 180 degrees I need, so 36 is my remaining angle. Good. And then angle 4. 16. 100 and? Yep. Easily with what we have already, it's supplementary. It's a linear pair with 36. Good. All right, let's turn our attention to number 2 now. We already know it's a parallelogram, but look at the markings I have on there. Got a better name for that one? Got a better name? Rhombus, right? All 4 sides are equal. Hey, whoa. Don't go on to the angles yet. Real quickly. I actually gave you more information than you needed. How do you make a parallelogram into a rhombus without saying all 4 sides are equal? How many sides do you think I need? Think I just need 1? That's not going to cut it, right? Would 2 cut it? Yeah, because it's already a parallelogram, so what would you know about the opposite sides? They're also equal. So ready? A parallelogram with 2, how can you describe these sides? Consecutive adjacent sides congruent. All right, you don't need all 4, just 2 consecutive sides congruent. All right, same thing. Get back in your group. Look at the properties here. If you know a couple properties, this will be done in a minute. All right, angle 1, 2, 3, and 4. Know your properties, you'll be done pretty quick. All right, what do you got here for the rhombus? 15, any angle you want. 59, diagonals bisect the angles, pretty easy. Opposite angles are congruent. Let's hear somebody different on this one. 18, another one. Yeah, diagonals are perpendicular. That's an easy one. 19, another one.
Angle 1 is 59. Angle 4 is 59. Sorry.
That's good. Diagonals bisect the angles. Good catch. And then how about little old angle 3 here? 24? Darn right it is. Diagonals are perpendicular. All right. This one I wanted to get to. Number 3. There's no markings on here. Right? And don't even think about pulling. Oh, it looks like this figure, so I'm going to call it this. That's not how we're rolling. Mathematically, you got to figure out. Well, first of all, it's already a parallelogram. Right? It's already a parallelogram. Any other angles we're going to know then if it's a parallelogram? Just by knowing it's a parallelogram. Any other angles I know? Angle 2 is 30, right? Because it's alternate interior with the 30 I gave you. All right, it's just next to a 60. What's this full angle here then? Now what's the figure? Rectangle. I can do that mathematically versus saying it looks like it. All right, back to work with your group. If you haven't done so already, back to work. 1, 2, 3, 4. Rectangle. Isosceles triangles. Angle 2 is already 30. That's taken. 1, 3, and 4 left.
Because that's perpendicular.
Oh, so you can, yeah. So you can.
All right, here you go. Back here. Guess I can go a little quicker now. 19. Got an angle?
Yeah. Angle 1 is 60.
Yep, because they form a right angle. Let's roll 6. Got an angle?
Angle, wait, for number
3.
Angle 2 is 30.
Angle 2 is 30. We got that already.
Okay, sorry. Angle 4 is 30.
Angle 4 is 30. Isosceles triangle. Yep. And finally, how about that missing angle? Oh, 25. I'll take that one. Angle 3 is 60 degrees. Forms our isosceles triangle with the other 60. All right, one more to go before we get off the angles and go to side lengths. What do we got here? What type of figure? Parallelogram with all sides congruent equals a rhombus. Don't say square either. This is not a square. Can't say square yet. You'll learn about that later on in the week. But this is confidently a rhombus. All right, go ahead. 1, 2, 3 again. 4. Know your properties. Goes pretty quick.
4 is 19. Oh, well, so the one that's like 24 is 58.
All right, back to business. Sorry there. Oh, 6. How about an angle here in our rhombus number 4?
Angle 1 is 22.
22 degrees, the tougher one. Yep, 22. I'll talk about that after I get some of the other angles. 8, another angle.
2 is 68.
Diagonals bisect, correct. That's 68. Let's see, 14, another angle.
Angle 3 is 68.
68, alternate interior with the given one, good. And then how about angle 4? 8. Oh, we already heard from you, Charlotte. 6, already heard from this one. 8, we're going back and forth. 8, oh yeah. 11.
What was it? Oh, sorry. 68.
Angle 4, Paul.
90 degrees.
Good. Any questions? One job. I know. Tell them one job. All right. I think we've done enough with angles of a rectangle and rhombus. How about we deal with diagonal lengths and side lengths? Let's first start with the rectangle. It's HIJK. Just a reminder, we label it clockwise and counterclockwise. Because if you start going HI diagonally, you're going to mess up the whole problem because the diagonals aren't where they're supposed to be. HIJK. Look, what is HJ in the problem? What's HJ going to be when I draw it in? Diagonal, right? And what's IK going to be? And it's in a rectangle. Want to tell me something? Diagonals of a rectangle? 11. We'll go somebody else here. 17. Diagonals of a rectangle. This problem's pretty easy once I know that property. Diagonals are congruent. 3x plus 5 equals 5x minus 9. Read it over though. Find x and the diagonal length. So I'm going to need somebody to do both for me here in a second. Find x and then find the length of each diagonal, which should be the same. Every year I make the same joke. There goes somebody's math ability. Past the window here in a second. Everyone here at the garbage truck?
Goofy.
Garbage. Math ability. Somebody's ability's going by. Okay, when you're ready, x and my diagonal lengths for me, please. Oh, number 1, Meg. X and my what's x here?
7.
And the diagonal lengths?
26.
Both 26 because they are congruent. Yes. All right, last one. All right, a little bit on the tougher side. This is a rhombus. Look at what I give you. What's GI in the diagram? GI, I know it's 8, but it's also a diagonal. Thank you. FH is 6, also a diagonal. Find the length of each. Find the length of a side. Hey kids, does it matter which side I find? Why not? Oh, it's a rhombus, which means they're all congruent. Good. So it doesn't matter which one I find. What am I going to do with this 8 and 6? One's 8, the other's 6. Diagonals now we're talking. Talk to me about diagonals of a rhombus. Maybe we can go further here because I'm not going to feed you this one and just say this is how you do it. One fact only, Lauren. One fact only.
They perpendicular or perpendicular?
They're perpendicular, so we have a right angle, and we talked when we did the properties, you have right triangles. Good. 8 and 6, still trying to get somewhere with that, right? 8 and 6. Those are the diagonal lengths. Let's keep going. Serena, what do you got for me?
Diagonals bisect each other.
Okay, so at least now on GI, I can put 4 and 4. And on FH, I can put 3 and 3. Everyone agree? Oh, I think I got something here. I got a right triangle where I already know 2 of the sides. And I'm trying to find the third. We have a device I think we've done multiple times this year that we could use in a right triangle only where I know 2 sides and find the third. Or maybe we haven't done it enough. Right triangle, I know 2 sides, trying to find the third. Hi, Caitlin. Pythagorean theorem. There it is. If I know 2 sides of a right triangle, I can find the third using Pythagorean theorem. Where are the 3 and the 4 going to go in? A, B, C, A and B. Yep. 3 squared plus 4 squared equals C squared. There it is, kids. There it is. Pythag. Oh, hey, get that in your mind. Rhombus, Pythag. Whew. 9 plus 16 equals C squared. C squared equals 25. So what do you got for C? Hi, Tim.
C equals 5.
Take the square root of 25, you get 5. There it is. 5. Doesn't matter which side, they're all 5. Continue on in your group. Keep going. You got the homework now. 10 minutes. Keep going in your group. Make sure you check your answers up on the classroom.